Hey everybody, Mr. Judson here. So today we want to talk about inverse of a function, or inverse functions. And first I just want to make sure we understand what that means. To get an inverse function, all you're doing is you're switching all the x and the y coordinates. Okay, so for example, we've got a parabola here. Coordinates would be 0, 0 for that point. This is 1, 1. This is 2, 4. So this is just the parent function of a parabola. Over here I've got negative 1, 1 and negative 2, 4. So if I was to switch all the x and y coordinates, that means over here this would become 4, negative 2. This would become 1, negative 1. When you switch this, 0, 0 is still 0, 0. And 1, 1, you switch that, that's still the same. Switch these, you get 4, 2. And so now if I plot those points, here's 4, negative 2, 1, negative 1, 0, 0, and then 1, 1, and then 4, 2, and what I get is a sideways parabola. Okay? But there's a little bit of a problem here because remember the vertical line test? You can only hit one point at a time. And so really what I just did here doesn't quite work. What that means is, in order to have an inverse of a function, we have this thing called the horizontal line test. Alright, so the horizontal line test says this. If you want to pause it just to write all this stuff in your notes real quick, you could do that. But a horizontal line test says that for an inverse to exist, a horizontal line can only touch one point at a time in the graph. And so when I go back and look at this parabola, here's my horizontal line, I'm touching 2 points at a time. And so what that means is there really isn't an inverse for this function. Unless we change the domain just a little bit. Now remember, the domain means what x values are okay to use. Well, what if I said x has to be greater than or equal to 0? Then what I've done is I've just eliminated part of this graph. Let me do this to right there. Okay, so now I'm saying let's only look at the right side of the parabola. Now I could have said the left side. Okay, it didn't matter which one I chose. I'll just keep things positive. And so we're only going to focus on the right side of the parabola. And so what that means is I need to eliminate some of these points. I need to get rid of both of those, which means I'm going to get rid of part of the graph down here. And so now what we could say is a horizontal line only touches this graph in one point at a time. Therefore, there is an inverse, and the inverse looks like this right here. Now, one thing that's kind of interesting, if I make a dotted line on my graph, and I make that dotted line go through the origin, and I call that line y equals x. It just means that my x and my y coordinates are always equal to each other. So I'm going to hit points like 1, 1, 2, 2, 3, 3, 5, 5. Down here I've got negative 3, negative 3. Okay? If two functions are inverses of each other, then they have to be reflections on either side of this line. So if I go over here and I grab this green square root function and I drag it back over here, then what I see is it looks like an inverse. This part gets flipped across the dotted line. Okay, so the green and the red parts right here are reflections of each other. There's a little curve here, and I should see my red curve down here as well. This isn't drawn very well. but I would see that reflection there as well, okay? So inverses are always reflections across the line y equals x. Let's write that down. So inverses are reflections across the line y equals x. We should be able to see, that reflection. All right, so how do you find an inverse function? To find an inverse, we need to follow two steps. Number one, because our definition is all the x and the y variables are switched, we're going to switch the x and y variables. Okay? What that means is everywhere where you see an x, you change it to a y. Everywhere where you see a y variable, you change that to an x. And then what we're going to do is we're going to solve for y. And that will give us the inverse function. Okay? So let's do a problem like this. We want to find the inverse of y equals, let's say we've got x minus 2 squared plus 3. And because this is a parabola and it doesn't pass the horizontal line test, I need to make sure that we're only looking at the part that's to the right of the vertex. So the vertex is at 2, 3, so I just need to make sure x is greater than 2. Okay, so we'll just write that here. X is greater than or equal to 2. That way we pass the horizontal line test. Okay, so I'm going to follow these steps. First thing I want to do is I want to switch my x and y variables. So x equals, in parentheses, y minus 2 squared plus 3. And now I just have to solve for y. Okay, so first I'll get the set of parentheses by itself. I'm going to move this 3 to the other side and do the opposite. And then I'm going to take the square root of both sides. So square root of this would be the square root of x minus 3. Square root of something squared is just what was on the inside, y minus 2. And now I need to move the 2 to the other side, and it'll become positive. So I've got y equals square root of x minus 3 plus 2. And what I'm going to do is I'm going to write it this way. Y to the negative 1 equals, I'm just writing this over here so I start with y. And I've got square root of x minus 3 plus 2. There's my inverse function. That little negative 1 right there. All right, so just like in the English language, we use the same word to mean two different things. There and there, right? T-H-E-R-E and T-H-E-I-R. Okay? Same thing here. If I ask you what this equals, a lot of people would say, well, that means 1 over x. Okay? Because as an exponent, negative exponents mean move it to the other side of the fraction bar. But this does not mean 1 over y. It means if y equals this function right here, then the inverse of that is this square root function. It's kind of like our intervals. If I use parentheses and I go 1, 2, is that the point 1, 2, or is it the interval from 1 to 2? Two things that look the same but have two different meanings. And again, how do we keep that straight? We just have to understand what we're talking about. If we're talking about inverses, then I know that means an inverse. If we're not, if we're talking about exponents, then I know that this means 1 over y. Just like this would mean 1 over x. So we have to keep those two things straight. On our calculator, there's an x to the negative 1 button, and it means this. It's not going to go and find an inverse function for us, okay? So, again, we got to kind of keep that straight. There are times where you do things on your calculator with matrices, which we don't talk about a whole lot anymore in math, but in that case it means an inverse, right? So the same button can mean two different things, even on a calculator. If I was to graph this, so let's just graph this real quick. If I graph the parabola that has a vertex at 2, 3, so let's see, I'll do that in blue. So 2, 3, it's right here. And if I'm only graphing values greater than 2, if I go over 1, 1 squared is 1. If I go over 2, 2 squared is 1, 2, 3, 4. And there's the right side of our parabola. If I graph this square root function, it's going up and to the right. My starting point is 3, 2. So that, I'll do this one in red. So 3, 2 is right here. And if I go over 1 unit, square root of that's 1. If I go over 1, 2, 3, 4, square root of that's 2. And so I get that function right there. And then if I go back and do my diagonal line, y equals x, looks like that, we can see that those are reflections of each other across that dotted line. All right, you guys go ahead and see if you can find the inverse for this. All right, so step 1, I have to switch the x and the y variable. So I've got x equals 2y plus 4 over 3. And now I need to solve for y. So to get y by itself, I'm dividing by 3, so I'm going to move it over here and do the opposite of divide. I want to multiply. So I've got 3x equals 2y plus 4. If anybody looks at this and you think to yourself, I'm not really sure if I should subtract 4 from both sides next or if I should divide both sides by 2. What you want to do is you want to think the opposite of the order of operations. Anytime we're solving an equation for a variable, we work backwards. So we've got to start at the bottom of the order of operations. I have to take care of whatever I'm adding or subtracting first, and then deal with whatever I'm multiplying or dividing by here. So, someone might go back at this and say, well, why didn't you subtract 4 first here? Well, because it's this whole thing divided by 3. Right? If that 4 was written out here, well then yeah, I would have moved it over and subtracted first. But I have to get that numerator by itself first by eliminating the 3. So I move it over and do the opposite. Now I'll move the 4 over and subtract, so I get 3x minus 4 equals 2y. And then I'll divide by 2, so I get 3x minus 4 over 2. So my inverse is 3x minus 4 over 2. And I can even check these on the graphing calculator if I wanted to. I can graph the inverse function and the original function and see if it looks like a reflection. So if I wanted to graph these two functions, I'll start with my original equation. So I'm going to hit y equals, and I got to put that numerator in parentheses. Okay, 2x plus 4, and we're going to divide that by 2. And then I've got my inverse function, which is in parentheses 3x minus 4, close parenthesis, and then divide that by 2. I made a mistake up here. I should have done 2x plus 4 divided by 3. There we go. And then I'm also going to graph the line y equals x. That way I've got that diagonal line so I can see the reflection on either side. So I'll go zoom option 4 and see there's the line y equals x. if I take this top line and reflect it, it looks like that's what's happening. So that would make me feel like I did things right. So there's a way you could check your answer to see if we're at least moving in the right direction. Okay. If I wanted to go with a bigger window, zoom option 6, these two graphs, if they're going to intersect that middle line, it's got to be at the same spot. Otherwise, it's not really a reflection, right? So this line goes through y equals x and then comes up here, and if you reflect it across the diagonal line, you get this piece down here. All right, let's try one more. Let's see if we can find the inverse of this function. So remember, f of x is our y variable, right? F of x means y. So if I want to rewrite this real quick, okay, you don't have to, but if just to see it, if you want to, you can. Now switch your x and y's. So x equals square root of y minus 3 plus 1. And now I just have to solve for y. So I'll bring this 1 to the other side and subtract it. I now need to square both sides. And so what I get is y minus 3 is equal to x minus 1 squared. I'm not going to multiply it out because what I'm going to get is an equation that's in vertex form. And we feel comfortable graphing that, so it makes sense just to leave it like that. And so bring that 3 over, and I've got x minus 1 squared plus 3 equals y. So my inverse function, now since we started with f of x, I'll write it this way. Okay, it means the inverse of f is this thing right here. X minus 1 squared plus 3. Now, technically I'm not correct yet, right? I haven't made any mistakes, I just haven't finished. So remember, a parabola, it doesn't pass that horizontal line test. So I need to make sure and say that we're only looking at part of the parabola. And what I want, if I go back up here and I think about graphing this, my starting point would be 3, 1. If I had a graph here, so we'd start at 3, 1, which is right here, and then my square root function, I go over 1, square root of that's 1, go over 4, square root of that's 2. There's my square root function. And so what I want is the right side of the parabola. So when I come down here and look at this, my vertex is at 1, 3. And so I want to make sure I say that x has to be greater than or equal to that x value, 1. That way I'm only looking at the right side of the parabola. And so if I go to 1, 3, if I go over 1, 1 squared is 1. If I go over 2, 2 squared is 4. And if I drew that diagonal line through here, we can see that those look like reflections. All right, so that's one thing we have to do for today, is we have to be able to find an inverse function. The second thing we want to do is we want to be able to determine if two functions are inverses of each other. So if f of x and g of x are inverses of each other, then f of g of x has to equal g of f of x, which has to equal x. if these two functions really are inverses of each other, then when you plug one into the other, either g into f or f into g, you have to get the same answer for both of those. And that answer has to be just the variable x. Okay? Now, when they ask us to check or verify that two functions are inverse, we really have to do both of these. Okay? We can't just do one and go, ah, there you go, see? Now, I'll tell you, I've never seen a problem where you get x for this one and then you get something different for this. I've never seen that happen. But the rule says you have to check both of these and you have to get x for an answer both times. Okay? So let's try an example here. So we want to check and see, are these two functions inverses? And so to do that, I would start by saying f of g of x. Remember, that's the same thing as f of g of x. It means we're going to take g and plug it into the function f. So I'm going to take this and plug it into here. And so if I do that, I've got 5 minus 8 times, I'm going to plug all of this stuff in place of x. And so I've got 5 minus x over 8. Because this is 8 over 1, those 8's will cancel, right? This is being multiplied, it's not being added or subtracted. So I can cancel those 8's, and then what I get is 5, and I need to distribute this negative sign. So minus 5, and then a negative times a negative, that's plus x. 5 minus 5, that's 0, plus x, that's x. So there we go, I got x for an answer. So I'm thinking, yes, these are inverses of each other, but before I decide for sure, I have to do g of f of x, which is the same thing as g of f of x. So now we're going the other way. We're going to take this expression and put it in place of the x variable here and see if we get x for an answer. You guys go ahead and try that one. Alright, so I'm plugging f back into g now. So I've got 5 minus whatever I'm plugging in all over 8. And this is getting plugged in right there. So 5 minus 8x. So I got to do what's in the numerator first. So in order to do that, I have to distribute that negative sign. So what I'm going to get is 5 minus 5, and then a negative times a negative is a positive 8x over 8. And 5 minus 5, that's 0, so I get 8x over 8. Since I'm not adding or subtracting, it's okay to say 8 divided by 8 is 1. And what we get is just x. So since I got that for both of these, I would say yes, f of x and g of x are inverses. And you got to show all this work to verify that. We can't just say yes or no and show no work. You know, we've got to be able to show why we're saying yes or no. Okay? And you guys should know that. Anytime you get asked a yes or no question in, let's say, a history or even an English class, the answer should never be just yes or no. It should be, well, yes, because, and then you explain why, or no, I disagree with that because, and then you explain why. If we just say yes or no to a question, everybody looks at us and they're waiting for a response. Well, why do you say that? You know, same thing here. We want to make sure and show why we're saying either yes or no. Let's try another one. All right, so let's go ahead and try this one. F of x is x cubed over 8. G of x is the cube root of 8x. Are those inverses of each other? You guys go ahead and try it. All right, so first I'm going to try f of g of x. I'll see what I get, which means I'm going to plug this back into where I see x here. So I've got something cubed over 8. I'm plugging this in there, so I'm going to have the cube root of 8x. So if you cube root something and then turn right around and cube it, you should come back to the same thing you started with. So that's just going to be 8x over 8. My 8's cancel, and I get x. So that part looks good. Now I need to do g of f of x. So even though I told you I've never seen a case where I get x here and I don't get it here, I still have to check it, okay? I can't all of a sudden take that as, oh, a shortcut, let's cut it in half. No, both of these have to equal x to be inverses. Okay, so we have to show that. So now I've got the cube root of 8 times, I'm going to plug this in place of x, so x cubed over 8. And so when I do that, the 8's cancel, and I get the cube root of x cubed, which is x. So yes, they are inverses. All right, that's what we have for today, so let me get you guys a homework assignment. All right, so here we go. We've got assignment number 8. This is Wednesday's portion. Page 99 to 100, we're going to do 15 to 23, just the odds. 29 to 32, we'll do all these. For 43 and 49, we're only going to do parts A, B, and C. Okay, we're not going to do part D. And then we're going to do 60 through 62. All right, there it is. That's what we have for today. You guys take care, stay safe. See you Thursday or Friday, and for those 2 days we're going to do our review in class. There will not be a video for that. All right, we'll see you.